So we are starting this test number 57. Here we are considering the chapter current electricity. Again, this chapter current electricity is divided into the two parts. Some part is in 11th portion in our HSC board and remaining is in 12th. So that part is combined and therefore we have to see this one paper 40 questions, test number 57. So I will read the first question. Question number 1. The masses of the three wires of copper are in the ratio 5:3:1 and their lengths are in the ratio 1:3:5. The ratio of their electrical resistance is तर रेजिस्टन्स आणि मास याच्यातलं रिलेशन आपण आता पहिल्यांदाच यूज करतो लक्षात. सो व्हॉट इज गिव्हन द मासेस आर इन रेशो 5:3:1. सो गिव्हन क्वांटिटी आर ऑफ लाईक दिस m1 h2 m2 h2 m3 is equal to 1 h2 3 h2 5. Oh sorry, 5 h2 3 h2 1 and the ratio of L1 h2 L2 h2 L3 is equal to 1 h2 3 h2 5 and we have to find the ratio R1 resistance R1 resistance R2 resistance R3 is equal to question mark. This is our problem. So resistance R resistance of a wire R is given by rho into L upon E, where rho is equal to specific resistance of material of wire here we are using copper material. L is equal to length of wire, capital A is equal to area of cross section, area of cross section of a wire. So this is basic equation 1. Multiply numerator and denominator by L. जनरली मासचं रिलेशन आपल्याला माहिती नाही म्हणून आपण काय करतो फक्त R डायरेक्टली प्रोपोर्शनल टू L म्हणतो आणि मग आन्सर चुकतो. इथे आपल्याला एक्झॅक्ट रिलेशन काढता येते पाहिजे. सो नाउ इफ यू मल्टिप्लाय बाय L then multiply numerator and denominator by L. Therefore R is equal to rho into L square upon A into L. This is equation 2 where A into L area cross section multiplied by length. Generally wire is cylindrical, so it is a V volume of wire, but volume of the wire. Then equation 2 gives resistance R is equal to rho into L square upon V. This is equation 3. Like this. जे आतापर्यंत आपल्याला इक्वेशन V1 एवढा. आता व्हॉल्यूमची व्हॅल्यू इन टर्म्स ऑफ मास आपल्याला इझिली अरेंज करता येईल. डेन्सिटीचा फक्त फॉर्म्युला V is equal to volume of the wire. But density of the material of a wire D is equal to mass of wire upon volume of wire. Therefore, D is equal to M upon V. Therefore, V is equal to M upon D. Put in 3. Therefore, R is equal to rho into L square upon M by D. Therefore, resistance R is equal to D into rho into L square upon M. This is the equation 4. Since D and rho are constant for copper material of wire, therefore R is directly proportional to L square upon M. L square upon M. So this is the equation. This is the equation capital A. So using a R1 S2 R2 S2 R3 is equal to L1 square upon M1 L2 square upon M2 L3 square upon M3 is equal to, now use this value. So L1 is equal to 1 square S2 3 square S2 5 square upon 5 S2 3 S2 1. So we are using these two ratio of masses and ratio of the length. So this is equal to 1 by 5 S2 9 by 3 S2 25 by 1. This is equal to 1 by 5 S2. This is 3 by 1 S2 25 by 1. So multiply by 5. So this is equal to 5 S2 15 S2 5 upon 5 multiplied by 3 upon 1 5 multiplied by 25 upon 1. This is equal to 1 S2 15 S2 125. So the resistances are in the ratio 1 S2 15 S2 125. So this is the correct ratio, and therefore the correct choice is the C. C is correct. So this relation is the important. तर हे रिलेशन आपल्याला डिराईव्ह करता यायला पाहिजे. So generally we know the relation between resistance and length and radius of the wire. So A is pi r square. So R is inversely proportional to R square, R is directly proportional to L. We have used this property. But here we have to use the masses of the wire, and therefore this arrangement must be done. Multiply numerator and denominator by L. So A into L is equal to volume of the cylindrical wire, and volume is given by density is equal to mass upon volume. Therefore volume is equal to mass upon density. Small d for density. So if we substitute this value in equation 3, then it gets rho into L square upon m upon d. So d density of the material, rho specific resistance, L square length square, and mass. So d and rho are constant for a copper material of the wire, and therefore R is directly proportional to L square upon m. So this is the ratio. R1 S2 R2 S2 R3 is equal to L1 square upon M1. So L1 L2 L3 are given here, and M1 M2 M3 are given here. So by using this value, the ratio of the resistances is given like this. So C choice is correct. Second MCQ. If a wire is stretched to make it 0.1% longer, its resistance will increase by 0.2%, increase by 0.05%. तर लेंथ वाढली म्हणजे रेजिस्टन्स इन्क्रीज होणार आहे, म्हणजे बी आणि सी तर कट झाले. आता ए आणि डी फक्त आपल्याला ट्राय करायचं आहे. सो द गिवन क्वांटिटी इज like this. Let L1 is equal to 100 is equal to original length. L2 is equal to L1 plus 0.1% of L1. So 100 plus 0.1 upon 100 multiplied by 100. So L2 is equal to 100.1. R1 is equal to R. R2 is equal to question mark. Change the resistance. Delta R is equal to question mark. So you have to find first R2, then delta R, like this. So now to solve this problem, there are two methods. First, method 1. So method 1 is like this. Resistance R is equal to rho into L by E. Therefore, R2 upon R1 is equal to rho into L2 upon A2, rho into L1 upon A1. So this is equal to A1 upon A2 multiplied by L2 upon L1. So this is equation 1. This is equation capital A. But stretching volume of the wire remains constant. Therefore, A1 initial volume before stretching is equal to final volume after stretching. Therefore, A1 L1 is equal to A2 L2. Volume is given by area cross section multiplied by length of the wire. V is equal to A multiplied by L, and therefore A1 upon A2 is equal to L2 new length upon L1. So putting 1 इथे subtract करा. So R2 upon R1 is equal to, this first bracket is L2 upon L1, second bracket is L2 upon L1, and therefore we can use this relation directly. Therefore, R2 upon R1 is equal to L2 upon L1 whole bracket square. You can directly start from this equation B, and therefore R2 upon R1. Now use this value 100.1 upon 100 whole bracket square, so that is equal to 1.001 whole bracket square, and by log you can take this log of 1.001. This log is from log table. So this is equal to, we are using this normal log table. So this is equal to 0.0004. So log of 1.001 whole bracket square is equal to 0.0008, and now anti-log of 0.0008 is equal to anti-log of 0.008, it gives 1.00. So this is equal to 1.002, so that is equal to 100.2 upon 100. So R2 is greater than R1. Therefore, resistance increases by delta R, and delta R is equal to R2 minus R1. So R2 is equal to 100.2 minus 100, so that is equal to 0.2. So delta R upon R is equal to 0.2 upon 100 multiplied by 100%. So that is equal to 0.2%. So resistance increases by 0.2%. This is the answer by method number 1. Therefore, the correct choice is E. Therefore, E is correct. This is method 1. Now, method 2. Error method. इथला जर रिझल्ट आपल्याला माहिती असेल तर आन्सर खूप फास्ट काढता येईल. लॉग पण घेण्याची गरज नाही, इथे आपल्याला लॉग घ्यावे लागले. तर हे रिलेशन यूज करून ही एक मेथड झाली. आता दुसरी मेथड याप्रमाणे. रेजिस्टन्स आर is equal to rho into L upon A. Since rho specific resistance and A area cross section are constant, therefore so this is equal to rho into L upon A into this is L square upon L, or rho into L square upon B. Since specific resistance rho and volume V are constant, therefore R is equal to K into L square. Say this is equation 2, or this is equation small. So differentiate R, differentiate equation A with this on both sides. On both sides. Therefore, dr is equal to K into 2L याचा डेरिव्हेटिव्ह घेतला into dl. This is equation B. हा L स्क्वेअरचा डेरिव्हेटिव्ह झाला. This is equation B. B by A dr upon R is equal to K into 2L into dl upon K into L square. So this is equal to 2 into dl upon L. Therefore, dr upon R is equal to 2 times dl upon L. So the equation can be written in percentage. Percentage change in R is equal to 2 multiplied by percentage change in length L percentage change in resistance R. So this percentage change in our problem, it is given 0.1%. So right hand side is equal to 2 multiplied by 0.1%. So 0.2%. Same answer. 0.2%. Percentage change in R. As L increases, therefore R increases, therefore percentage increase in resistance R is equal to 0.2%. Percentage increase, and therefore resistance increases by 0.2%. Percentage increase in resistance is equal to 0.2%. Therefore, A is correct. आन्सर काही बदलणार नाही, फक्त आपल्याला लिमिटेशन माहिती पाहिजे. इन दिस केस दिस पर्सेंटेज चेंज इन लेंथ मस्ट बी स्मॉल, लेस दॅन 1 or 2%. अदरवाइज आन्सर विल बी रॉंग. तर दोघे मेथड मी सांगितलेलं आहे. फर्स्ट मेथड इज ॲप्लिकेबल every time. Second method has limitation. So second method is called as the error analysis. So if there is a error in the measurement of length of the wire, then there is a corresponding change, corresponding error in the measurement of resistance. So that dr upon r, it is the relative error in the measurement of resistance, like this. So दोघे मेथड लक्षात ठेवा. Second method is the differential method. It is a new method. It can be used in many chapters. So resistance of the wire is given by rho into L upon A. L is length, A is the area of cross section, multiplied by length. So rho into L square upon A into L. A into L is equal to volume of the wire. So for a given wire, volume V is constant. For a given material of the wire, rho is constant. So rho and V are constant. Therefore R is K L square, where K is a constant. It is rho upon V. K is a constant of proportionality. Now differentiate equation on both sides. L is a variable, independent variable, and R is a dependent variable. So these are two variables. So we have to differentiate. On LHS we will get the differentiation of R. On RHS we will get the differentiation of L, length L. So R has derivative dr. L square has derivative 2 times L into dl. So if we divide these two equations, we get this equation. Percentage change in resistance R is equal to 2 times percentage change in length L. In our problem, the percentage change in length is given 0.1%, and therefore percentage change in resistance is equal to 0.2%. Now the length increases by 0.1%, therefore resistance will increase. Therefore this is the percentage change. So change may be increase or decrease. In this case it is a increasing change because length increases. So percentage increase in the resistance R is equal to 0.2%. So resistance increases by 0.2%, resistance increases by 0.2%. Answer will remain the same. Next, question number 3. Identify the incorrect statement. So out of 4, 3 are correct, only 1 is wrong. So what to select it? Identify the incorrect statement regarding a superconducting wire. So we are using the wire having material superconductor. A, the transport current flows through its surface. The transport current flows through the entire area of cross section of the wire. It exhibits zero electrical resistivity and expels the applied magnetic field. It is used to produce a large magnetic field. So we know some property of the superconductor and what we use them. So those properties are like this. Properties of superconductors. One, their electrical resistance R is almost zero. Therefore, electrical resistivity rho is also zero. Electrical conductivity sigma is equal to infinity. Therefore, they are called as a superconductor. Since R is equal to 0. Maximum or very large current flows through it. There magnetic field produced by current. कुठलंही क्वेश्चन घ्या आपण 11th मॅग्नेटिक इफेक्ट ऑफ इलेक्ट्रिक करंट मध्ये विचारले produced by current I. Therefore, our superconductors I is large. Therefore, B is also large. Therefore, C and D are correct statement. आपल्याला wrong statement भेटली. Now, the flow of the current. Current in superconductors always flow on its surface. Therefore, A is the correct statement. And hence B is wrong statement. Therefore, B choice is the correct. आपल्याला wrong statement select करायचे. So B choice is the correct. Correct choice of equation question 3 is the B, like this. Question number 4. A given piece of wire of length L and radius R is having a resistance capital R. The wire is stretched uniformly to a wire of radius R by 2. What is the new resistance? तो आपण क्वेश्चन नंबर 2 मध्ये लेंथ इंक्रीज करत होतो. व्हॉल्यूम रिमेन कॉन्स्टंट, therefore when length increases the radius decreases. इथे पण radius decrease होते, जे लेंथ वाढणार आहे म्हणजे रिझल्ट आपल्याला काय मिळेल, रेजिस्टन्स विल increase. So answer will be more than R. So all the answers are more than R. So again we will use the same relation. R1 is equal to R. R2 is equal to R by 2. R1 is equal to R. New relation R2 is equal to question mark. So resistance R is equal to rho into L upon E. Okay. R2 upon R1 is equal to rho into L1 upon A1, rho into L2 so this is equal to A1 upon A2 into bracket L2 upon L1 whole bracket square. This is equation 1. Now again we will use the same property. During stretching of wire, volume of the material of wire on the wire remains same. Therefore, initial volume of wire before stretching is equal to final volume of wire after stretching. Therefore, A1 L1 is equal to A2 L2. Therefore, L2 upon L1 is equal to A1 upon A2. Put to in1 ही वैल्यू इसे सब्स्टिट्यूट करा, तो R2 by R1 new ratio is equal to A1 upon A2 first bracket as it is, A1 upon A2 second bracket as it is, so A1 upon A2 whole bracket square. So we can use this equation directly, equation A. But area of cross section of a wire E is equal to pi r square, where r is equal to radius of cross section of wire. Therefore, A1 upon A2 is equal to pi r1 square pi r2 square, so that is equal to r1 upon r2 whole bracket square. This is equation 3. Put 3 in E, ही वैल्यू इसे सब्स्टिट्यूट कराओ. Therefore, R2 upon R1 is equal to R1 upon R2 whole bracket square and bracket the square. इसे A1 upon A2 whole bracket the square है. Therefore, the final relation is R2 upon R1 R2 upon R1 is equal to small r1 upon small r2 whole bracket raised to 4. So r upon r by 2 whole bracket raised to 4. So that is equal to 2 raised to 4, that is equal to 16. And therefore, the new relation R2 is equal to 16 times R1. R1 is equal to R. So new relations after stretching R2 is equal to 16 times R. The पहिला रेशन R असेल तर नवीन रेशन आपल्याला 16 टाइम्स R मिळेल, म्हणजे करेक्ट चॉईस C मिळाला. C is correct. The choice C is correct. तर इथे आपण रेडियसमधलं व्हेरिएशन कन्सिडर केलेलं आहे हलकं. So you can use this relation directly. R2 upon R1 is equal to R1 upon R2 bracket raised to 4, like this. So this is the relation in terms of length. Last time we have seen this. So totally the relations are like this. R2 upon R1 is equal to L2 upon L1 whole bracket square is equal to A1 upon A2 whole bracket square is equal to R1 upon R2 whole bracket square. जर लेंथ मधला चेंज दिला असेल तर हा फॉर्म्युला यूज करा, एरिया मधला चेंज दिला असेल तर हा फॉर्म्युला यूज करा आणि रेडियस दिले असेल तर हा फॉर्म्युला यूज करा. सो दिस 3 types of relations are required while solving the problem during this. So during the stretching of the wire we can use any one of the relations like this. So this is a very important relation. हे दोन प्रॉब्लेम आपण याप्रमाणे कंबाईन करू शकतो. Okay, we will stop here. So we will see remaining question in the next session.